finished, okay? Let's take a point which is below y equals minus 1. Okay? For example, like let's go through 0. I actually do this one for you, 0 minus 2. Okay? Let's just take that point, 0, negative 2. Okay, well, if y is something like negative 2, the slope is a negative on the y, and that's going to be negative. Negative times negative is a positive, right? So the slope increases. It's a positive slope. So we increase, 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 but we can't go past that equilibrium. So therefore we asymptote over there. And the question is basically what happens over here, okay? And what happens here, you don't know this from the analysis, but there's actually a vertical asymptote over there, okay? I'll just kind of draw it over here. It asymptotes over there, okay? And I'll just finish by telling you what the solution is, okay? Again, this is something which you can verify. I don't expect you to derive it. If you have the differential equation dy dt is equal to y paren 1 minus y squared, and let's do the initial condition, 0, negative 2, and y of 0 is equal to negative 2. So it's this curve over here, okay? Okay? You actually can solve that analytically. And the solution looks like the following. It looks like minus 2 e to the t, okay, divided by the square root of 4 e to the 2t, take away 3, okay? And you can see where you're going to get into trouble when the denominator goes to 0, right? So y infinite when what? The denominator is 0, you get 4 e to the 2t equals 3, right? So e to the 2t is equal to 3/4, right? 2t is equal to the natural log of 3/4, and then t equals 1/2 log of 3/4. And if you work that out numerically, it's about minus 0.1438. Okay? That's where this asymptote is. T equals minus 0.1438. Okay? But nothing is violated as far as our autonomous theory goes, okay? We know that. We know basically that without question that we're in this region, we have a positive slope, so therefore we do approach y equals negative 1 as t goes to plus infinity, okay? And when we go over here, it gets more and more vertical, right? The slope, it gets more and more, negative to infinity, okay? But we don't know, maybe it goes past this point, okay? But in this particular case, we have the algal solution, which I gave you, and it comes out there actually is a vertical asymptote at that point, okay? So this would be the piece of information that you can't get from the analysis. But many times you're interested in equilibrium solutions like this one or this one, and that gives you the qualitative behavior right away. And again, like I said before, if I were to solve for any of these regions over here analytically, I get something equally complicated to that. And if you look at that, it's very hard to tell the nature of the curve. So it's kind of ironic that, yes, many times having just a qualitative picture like this is more informative, okay, depending on what you want, than having the analytical solution, okay? And many times in engineering, that's all you're interested in. Okay, we're going to get, when we get together next week, we're going to continue this. We're going to talk about stability, okay? You know, is the thing both stable or not? And in engineering, that's critical, okay? If you're designing a flight control system for an aircraft, okay, it better be stable, right? In other words, there are certain operating conditions for nominal flight, and if there are gust loads or other types of things, passenger movement, right? The guidance system has to adjust for that, okay? And you want to make sure that it's stable, that a slight perturbation doesn't throw you off. So we'll get into that thing on, I guess, on Monday, okay? But actually, you can probably start the homework. It's not going to be due. It's posted, so why don't you just kind of start it on it, okay? Certainly the ones with the, I think there are 2 problems on direction fields, okay? You should do those. And you'll notice in the homework there's no due date yet, okay? That'll come up next week. But, you know, you definitely should be able to start on this also, okay? So I'll see you guys next week.